today we're going to look at solving log equations. So yesterday we solved exponentials. Today we're going to solve logs. Tomorrow or Monday we're going to solve logs in a different way as well. So if we have the first type, which is just a log equals a number, our general steps here is to condense, which is what your quiz was just over, and isolate the logarithm, so it has to be by itself. Then we're going to rewrite it in exponential form, and then we'll be able to solve. But it also says check for extraneous solutions, because just because we get answers for x doesn't mean that they're actually going to be viable numbers, because our parent function for a log, okay, so for the parent function for any log has an asymptote at x equals 0, right? Has an asymptote at x equals 0, has an x-intercept at 1, 0, and then looks like that. If the base is more than 1, it could look like this if the base is less than 1, but either way, the domain would be the same. Okay, so the domain here, or our parent function, was f of x equals log base b of x, and the domain here clearly is 0 to infinity, and I don't include either one of them. If this is my domain, this is my function, or my graph, then do you think, can I take the log of any base of 0? No. If my domain's 0 to infinity, I don't get to use 0. Do I get to take the log of a negative number? No. Okay, so anything you take the log of, it just has to be a positive number. Okay, can't be 0, can't be negative. So we have to think about that when we actually find our solutions here. All right, so let's solve a few and see how that works. We'll go ahead and do number 1. So here, this log is already isolated and condensed. So I just have a log that's all by itself equal to a number. So when I have that, I can rewrite it in exponential form. That makes it 2 to the 7th power equals 3x minus 4. Right? Then what is 2 to the 7th power? 4, 8, 16, 32, 64, 128, right? So I got 128 equals 3x minus 4. Add 4 to both sides, I get 132 equals 3x. So what does x equal? 44. Good. Now, before I box it and move on, I got to see if that answer works. Now, clearly 44 is in the domain, but that's not what I'm trying to figure out. If I take 44 and substitute it back in, I don't care what the actual value is, but if I take 44 and multiply it by 3 and subtract 4, is it going to be a positive number? Yeah, and that's all I care about. Since it's positive, it works, and I'm good to go. Okay. Why are you shaking your head no at me?
Oh, I was thinking something.
Okay, but you understand why it's this? Okay. All right, so let's look at number 2. I have a single log equal to a number, so I can rewrite it. The base here is what? E, so I've got e to the 9th equals 2a. Trying to get a by itself. Here I had 2 to the 7th. I had to actually figure out 2 to the 7th. E to the 9th is just e to the 9th because we wanted it in exact form. So now I would just divide both sides by 2. A equals e to the 9th divided by 2. All right, so then I got to think, all right, if I substitute that back in here, 2 times e to the 9th over 2 is just e to the 9th. That's definitely a positive number, and this is my answer. Okay. Any questions at all? All right, let's look at number 4. So at number 4, my log is not isolated, so I'm going to have to actually do a little stuff to make that happen. So the first thing I want to do is I'm going to move this 4. I'm not going to, the 2 could come up here and be an exponent, but I'm not going to do that just yet. So I've got 2 times log base 9 of k squared plus 2k equals 1. So again, this 2 could come up here and be an exponent on this binomial, and then I'd have to square it, which is fine. There's nothing wrong with that. But I have another option, because the opposite of multiplication is division. I could just divide by 2. And if I divide by 2 and get 1/2 on the right, I won't have to square this thing. Make sense? So even though it wouldn't be wrong, I think it would be easier not to. So I'll get log base 9 of k squared plus 2k equals 1/2. Now that my log is isolated, now I can rewrite it. So I'm going to take 9 to the 1/2 power and set that equal to k squared plus 2k. What's 9 to the 1/2 power? 3. So I get 3 equals k squared plus 2k. That's a quadratic, so I set it equal to 0. So I get 0 equals k squared plus 2k minus 3. Then I factor. K and k, so that'd be a positive 3 and a negative 1. So my possible k values are negative 3 and 1. And I have to check both of them, because maybe they both work, maybe one works, maybe neither one of them work. So if I take negative 3 and I substitute it in here, I'm going to square it, and that becomes a positive 9 plus a negative 6, so that's still positive, so negative 3 works. I put the 1 in there, everything's positive, so they both work and it's good. We good? Questions? All right, let's look at number 5. So number 5, I have 2 logs being added, which means it turns into 1 log that has multiplication. So log base 4 of 2v plus 3 times 2v minus 3. But I can't just leave it like that, because that's not clear on, maybe this is just log base 4 of 2v plus 3, and then that times 2v minus 3, but that's not what we mean. So to kind of do this so we can tell that it's all in one thing here. And that equals 2. So I have the log isolated. I can go ahead and rewrite and make this 4 to the 2nd power equals these 2 multiplied together, which I can go ahead and multiply them when I take them out of that. Is that going to be pretty easy to multiply? Yes, because that's a what? Difference of squares. So this is 4v squared minus 9. Right. 4 squared is 16, and then I have a quadratic, so I need to move it over. So this will be 0 equals 4v squared, and then negative 9 minus 16 is going to be negative 25. Can I factor that pretty easily? Yes, because it's another difference of squares. So this will give me 2v plus 5, 2v minus 5. So my possible v's. Now, there's nothing wrong with doing plus or minus. However, since we are checking each one and one of them could be no good, then I'm going to go ahead and write them separately. So I'd have negative 5/2 and 5/2. Then I have to check my solutions. Negative 5/2, if I put it in here, negative 5/2 times 2 is negative 5. Negative 5 plus 3 is a negative number, so this one doesn't work. Then 5/2 times 2 is 5 plus 3 is fine. And then 5/2 times 2 is 5. 5 minus 3 is positive, so that's fine too. So my answer is just 5/2. Everybody okay with that? Awesome. All right, so my thing disappeared again. And I might have told you all this the other day, but I was editing one of these, and all my fraction bars disappeared, and I didn't know why. And down in the bottom left-hand corner, I saw this. And they were all like in the bottom left-hand corner having a party. I don't know why that happens when I edit PDFs sometimes, but it does. So, and they don't always end up having a party in the corner. I don't know where they go, but that should be a 1/3. They just mess with me, I think. Why does it have to be positive when you plug it in? Because if you're taking the log of anything, you cannot take the log of 0 or a negative number. Because this is your graph of a log base whatever. So like log base 2 of x would basically look like this. So whatever I substitute in, whatever this is, has to be a positive number. That's the only thing that's allowed in your domain. The domain of the log is positive numbers only. That's all you get to. That's just like if you have the square root of x, it's the same domain. You don't get to take the square root of a negative number. and get a real number. I mean, you can, but you get an imaginary. And you can take the square root of 0, but you can't take the square root of a negative number. Here, you can't take the log of a negative or 0. Okay, does that help? All right, so back here. Now, in this case, where I did not want to use this as an exponent here, because it was an easier way to do it, here I think I do want to use it as an exponent because that would be kind of helpful to knock that number down a little bit. So this would be the natural log of 27 to the 1/3. What's 27 to the 1/3? 3. Okay, so that becomes the natural log of 3 plus the natural log of x minus 5, and that equals 4. Then I still need to combine them. So this becomes the natural log of 3 times x minus 5 equals 4. So now that it's one log, I can go ahead and rewrite it. My base is e, so this would be e to the 4th equals, and I'll go ahead and distribute this as I rewrite it. This gives me 3x minus 15. Trying to get x by itself, so this becomes e to the 4th plus 15 equals 3x. So then x equals e to the 4th plus 15 all over 3. And I got to check it just like I checked the rest. When I substitute in, this is nothing because there's no variables in there. It is what it is. But basically, x is going to have to be greater than 5, right? So I don't get 0 or a negative number. I don't necessarily know what e to the 4th is, even in estimation, and I don't care. I do know, though, that 15 divided by 3 is 5. And if I add something to 15 before I divide by 3, is that definitely going to be more than 5? Yes, and that's all that matters, and that's my answer. Okay. So use some reasoning skills with your, you don't necessarily have to estimate everything. Oh, y'all are silly. Okay. So I'm going to add these two logs together, which means I'm going to condense it to a single log. This becomes a multiplication, n minus 3 times n plus 1, and that equals 5. So I'm going to rewrite it. 2 to the 5th equals, and I'll go ahead and multiply this out. That's going to give me n squared, and then I'd have a positive n and negative 3n, so that's negative 2n, and then minus 3. This is a quadratic. I want to set it equal to 0, so I want to subtract this over there. What is 2 to the 5th? 32. So this will be 0 equals n squared minus 2n, and then minus 35 once I subtract that 32 over there. Then I need to factor it. So go ahead and factor it and find your n's. Okay, so did you get negative 5 and positive 7? Are they both going to work? No, because when I substitute in negative 5 right here, that gives me negative 8. So that one's no bueno. 7 in here gives me a positive 4. That would give me a positive 8. So it's just n equals 7. Everybody okay with that? Awesome. All right, so now I'm condensing here, and this is subtraction, so it'll become division. So I have log base 2 of c squared over 3c minus 5, and that equals 2. Can I cancel this c with one of these? No, that'll make me disown you. Okay, so then I'm going to rewrite this, and I get 2 to the 2nd power equals c squared over 3c minus 5. Okay, so to solve this, I want to multiply both sides by the denominator. The left-hand side is clearly 4. So I'll multiply this by 4, and I'll go ahead and distribute as I do that. So I'll get 12c minus 20 equals c squared. So then once again, I have a quadratic, so I'm going to set it equal to 0. So you set it equal to 0, factor, find your C's. So I got 2 and 10. All right, and do they both work? No matter what I put in here and I square it, it's going to become positive, so that's fine. And then 2 times 3 is 6, minus 5 is positive, and then the second one will be positive, so that is it. Okay, we good? All right, so that's when you have a log or logs equal to a number. Another option is to have 2 logs equal to each other, okay, or a log on both sides. So your we still have to check the solutions the same way. We still condense the logarithms on each side. Then we have a one-to-one property for logs, just like we did for exponentials. So the one-to-one property, if log base b of x equals log base b of y, then x equals y. That should make sense, right? Hopefully. And then we solve and once again check for extraneous solutions. All right. So the left-hand side looks just fine. The right-hand side, I have that 1/2. So I'm going to go ahead and make that an exponent up here. So this will become log base 4 of 4p plus 3 equals log base 4 of 16p to the 4th to the 1/2 power. So log equals log, they have the same base, so that means these two pieces have to be the same. So that gives me 4p plus 3 equals, and then I can go ahead and take that to the, what's 16p to the 4th to the 1/2 power? Yeah, it's the square root of it. Yeah, so then what is the square root of that? 4p squared. Good. All right. Quadratic once again, so set it equal to 0. So 0 equals 4p squared minus 4p plus 3. A is not 1, so, oh, minus 3. Yeah, I was like, something's not right. Thank you. Minus 3. I'm going to factor by grouping. That gives me a negative 12. Oh my gosh, and that's a 10. Negative 12. 0 equals 4p squared. So I need two numbers that multiply to give me negative 12, combined to give me negative 4. So I'd say that's a negative 6 and a positive 2. And factor by grouping should hopefully be, or factoring this in general, I don't care how you do it, should be a piece of cake for you by now. That's what you get when you factor. So P is going to be negative 1/2 and positive 3/2. Right. Then I check them. So if I take negative 1/2, substitute it in here, that would give me negative 2 plus 3, so that's positive. The negative 1/2 over here, I take it to the 4th power, anything will be positive, so that's good. 3/2, that's all positive, so they both work. Alrighty. One last one, and we have exponents to take care of on both sides here. Right? So this will be the natural log of a plus 1 squared equals, now this is going to be, I need to condense this as well. So this will be the natural log of what? What do I do with these two numbers? Divide, so it'll be the natural log of 16, and then that 3/2 power can go on to 16. Then I have the logs are equal, so those two things have to be equal. I'll go ahead and square this when I take this out. It is not a squared plus 1. It is a squared plus 2a plus 1 equals, and then what's 16 to the 3/2 power? Isn't that the square root of 16 cubed? What's the square root of 16? 4. What's 4 cubed? 64. Okay. So then go ahead, set it equal to 0, and factor, find your a's. Substitute it back into the original one. -9 plus 1 is a -8, so that one won't work. 7 plus 1 is 8, so that's good. And then over here, there's not a variable, so in the end, your answer is just a equals 7. Okay. What questions do you have? We good? Awesome. Your assignment is in Delta Math.